Hi students, Mr. C here at the wood shop, and as remember, we're talking about CNC software today and the CNC machine. So we're talking about building cabinets for a kitchen by using a CNC and using software that's very user-friendly. Now granted, I do understand a significant amount of different cabinet software programs out there that are very specific for the cabinet making industry, and they're fantastic. But for us, where we're doing all kinds of different projects, I want to show you that you can use a very user-friendly CNC software that I can teach you in a very short period of time to go ahead and cut out cabinets efficiently, okay? Now, it doesn't have a lot of the bells and whistles that some of the higher-end software programs have because it's not designed for that. This is designed, I think, for this application of working in a shop with students so they can just get their feet wet, and then we can go ahead and use some of the other software packages that we have for the program if you really want to dive into the CNC designing and the software for cabinet making, okay? So for right now, what I'd like to address is some of the different components here that we talked about is this upper cabinets for a kitchen. Now, I was talking about utilizing the software. Now, up here on the smart board, I'm going to let you see exactly what my computer is doing. Now, you can see my cursor, I hope. And what I'm showing you here is these are the parts to two upper cabinets or wall cabinets, depending on which way you want to talk about it, but it's the same thing. We have one small upper cabinet that would go above a refrigerator, and then a larger upper cabinet that would be, let's say, a cupboard, where you have all your cups, dishes, glasses, or whatnot. So what we've done here is we have all the programming done. Like in the first video I talked about was how to go ahead and set up the parts as far as how to lay them out, and you can use coordinates to get exact size dimensioned pieces. So what I've done is I've took the liberty to go ahead and put the other parts to a second cabinet on this sheet to optimize this one sheet so we don't have a bunch of scrap. Now you may notice in this area right here where I have the cursor, these pieces here are for base cabinets, but I just did not want to waste this material. It isn't big enough to make other parts for it that are large parts for upper cabinets. So what I'm going to do is I'm going to use this part of the material for other base cabinets. Okay? So what I've done is let's just go ahead and let's talk about the machining portion of it, or the tool pathing of a cabinet. Now over here you'll find that I have all these indexing holes that the cursor is on this side and this side. This is the left and right sides to the larger cupboard or upper cabinet. And then over here, these holes here are the holes for the adjustable shelf, also for the cabinet that's going to go above the refrigerator. Now what I've done is I have linked all these holes together. So now what I did was I clicked on one hole and it highlighted all of them in a magenta. That means that all of these are highlighted together, so they're all basically, they're linked. So that way when I go ahead and create a tool path, it will cut all these different holes out. All right, so what I'm going to do is I'm going to come over here to the tool pathing side of the software. What I'm going to pick is a pocket, because basically drilling a hole is a pocket. Since I highlighted all the holes in the magenta, I'm going to click on that. Now when you do that, it says pocket toolpath, starting depth. The Z is at 0. I want to start at the top of the material, just like we set it up. The depth of cut, I want to go 0.375, which is half the thickness of the material. That's 3/8, okay? Then the tool that I have selected is an end mill that's a 1/4 inch diameter. And if I go ahead and press edit, you can see that it pulls up the information on this particular tool. Now this tool is an end mill, it's a 1/4 inch in diameter. The width and depth capacity, it's not a big, it's within those parameters. The units is in inches, the diameter is 0.25. The number of flutes is 2. We'll get into the flutes and the speed rate later when we talk about chip load and how to set that up properly. That's just a different day in a different video, but we will address it. The depth per pass is 0.125, so 1/8 of an inch per pass. And the step over is 1/10 of an inch or 40% of the width of the bit itself or the end mill. The spindle speed I have set at 21,000 RPMs. Our machine maxes out at 24,000 RPMs. It is not necessary for us to run that fast. The feed rate is going to be in inches per minute. And the feed rate, okay, I have it set at 300 inches per minute. The plunge rate at 35 inches per minute. And because we have an automatic tool changer, this is in tool number 4. So I'm all set with that, and all those parameters are correct, so I'll press OK. Now, I can go ahead and I have some other things that I could address if I wanted to, but with this particular tool and what we're doing, we do not have to offset raster or anything like that, just because it is just going ahead and plunging down and essentially just drilling a hole and indexing it for our adjustable shelves. So we'll press calculate, and this is going to show the piece of material, and the tool path is in this red line, and that's how it's going to go ahead and proceed to cut on the board. What I can do is I can come over here and press preview toolpath. You see where my cursor is? I'm going to slow the speed down on here so that way it's easier to see, because it's awfully fast sometimes. So I'm going to go ahead and slow down the speed, and I'm going to press this. Now you'll see how quickly all of a sudden all these holes appeared. Let me try just reset that, because I think it was too fast. Okay? So what I'm going to do is I'm going to reset preview selection, and there it goes again. Still very, very fast as far as showing you the holes. The nice thing is I have all my small cabinet indexed holes, all my upper indexed holes, and this is the very first tool path that would be appropriate for me to use on this sheet. Now what I'm going to do is I'm going to come up to the top where it says 2D view right up here. I'm going to click that button, and then this is going to bring me back to my designing side. Now the next thing I'm going to do is I'm going to cut the woodworking joints that I need, and that's dados and rabbets. So what I'm going to do is I've already linked the dados and rabbets as one. So when I go ahead and I click on the magenta, or I click on one of them, all of them turn the magenta. That means they're highlighted. That means they're all engaged. Okay? So now what I can do is I can go ahead and set up a tool to go ahead and cut that material. Now what I'm going to do is I'm going to close this right here. Now I still need another pocket. So I'm going to press the pocket tool. Okay? Now the end mill that I want to select, okay, well I'm sorry, I went too fast. At the top, the cutting depths, I want to start at the 0, 0. The cutting depth is exactly the same, 0.375 or 3/8. Now I'm going to select the tool that I want for this one. This brings up my tool library, and what I want to go ahead and do is select a 1/2 inch end mill. And this one happens to be compression bit. It's 3 flute. It's an end mill. The diameter is a 1/2 inch. Number of flutes, as it says, is 3. The passing depth, I can go 1/4 inch per passing depth. I want to do that just so I can clean up in the second pass. The step over, 0.2 at 40% again. The spindle speed for the chip load on this one is at 18,000 is correct. The feed rate is correct at 600 inches per minute. Our machine can run at 600 inches very quickly, and it's within the parameters of how it was built. The plunge rate at 180 inches per minute, and it's in tool holder number 5. I press select. Okay, now I've set up my parameters on my tool and select this up. Now, ramp, plunge, I want to go ahead and click this, and I want to move it. I want to plunge this over 5 inches on an angle, or ramp this on an angle. That way it prolongs the life of the bit. Okay, so I've done that. Now I can go ahead and press calculate. Now this is going to show me again with the red lines. The red line is where the head is going over, and then the blue line is where we're going to cut. So the speed is slowed down. I'm going to go ahead and press preview selected toolpath. And it's going to go ahead and see, as you can see, this is cutting, and it's cutting the depth here and going back and forth. And this is what it's going to do. Like I said, I slowed down the speed so this way it'll allow for you to see exactly how this is going to work. And when we go ahead and cut the real material, this is exactly what you're going to see on the real material on the machine. Okay? So I sped that up just a little bit just so you can see how this is done. And it's utilizing the whole thing.